Knowing how to calculate a least common multiple is something that is routinely tested on the ACT. For review, the least common multiple is the smallest positive number that is a multiple of two or more numbers. In this video, we're going to review least common multiple and how to calculate it. The simplest examples of calculating a least common multiple involve two numbers when one or both of those numbers is a prime number. All you need to do there is multiply the two numbers together to get the least common multiple. So when we have 2 and 3, both of them are prime numbers, so we multiply them together to get the least common multiple of 6. For 7 and 11, again, they're both prime numbers, so we multiply them together to get 77 as the least common multiple. For 53 and 107, after looking at them for a couple of seconds, we can determine that, yes, 53 is a prime number, and so is 107. So we can multiply those together as well to get the least common multiple of 5,671. What about examples of finding the least common multiple when neither of the numbers is a prime number? For that, we can actually use something called prime factorization to figure out the least common multiple. Prime factorization involves breaking up a number into its prime factors. So for 6, when we multiply 2 and 3 together, we get 6. 2 and 3 are both prime numbers, so we are done with the prime factorization of 6. 9 can be broken down into 3 times 3, and again, 3 is a prime number. So we're done with the prime factorization. Now, to get the least common multiple, what we do is we figure out the number of times maximum that each prime factor shows up, and we multiply them together. So we have 2 over here, and it only shows up once in the prime factorization of 6 and 9. So we're going to drop down a 2. Next we have 3. 3 shows up one time in the prime factorization of 6, but it shows up 2 times in the prime factorization of 9. We take the maximum number of times it shows up. So now we're going to drop down 3 2 times. Now we have 2 times 3 times 3, which is 18. And 18 is the least common multiple of 6 and 9. Let's do another example. We have 12 and 14. So let's break down 12 into its prime factors. So we have 2 times 6, and then 6 can be broken down into 2 times 3. Next we have 14. 14 can be broken down into 2 times 7. So now we have 2 appears in both the prime factorization of 12 and 14, but it appears a maximum number of times twice. So we're going to pull it down 2 times, so 2 times 2. 3 appears one time in the prime factorization of 12, and none in the prime factorization of 14, so we're going to pull down 3 one time. Same goes for 7. It appears once in the prime factorization of 14, so we're going to pull it down one time. 2 times 2 times 3 times 7 is equal to 84, and 84 is going to be the least common multiple of 12 and 14. Next, we have 8 and 13. To find the least common multiple, you may recognize that 13 is a prime number. So we should just be able to multiply 8 and 13 in order to get the least common multiple. However, let's apply prime factorization just to double check that that method is in fact accurate. So we're going to break down 8 into 2 times 4, and then we're going to break 4 down into 2 times 2. 13 is already factored. It's just 13 times 1. So we don't need to build a factor tree. Now we see that 2 appears 3 times in the prime factorization of 8. So we can pull down 2 times 2 times 2. And then 13 appears once, of course, so we can bring down a 13, so times 13. Of course, 2 times 2 times 2 is equal to 8, so 8 times 13 is 104. So yes, our method works, and so does our original assumption that 13 is a prime number, so we can multiply 8 and 13 to get the least common multiple. What if we have 3 numbers? How do we find the least common multiple then? Actually, we can use the same exact method with prime factorization that we've been using. So if we have 9, 21, and 24 and wanted to find the least common multiple, we can take the prime factorization of 9, 21, and 24 and use the method described above in order to figure it out. So 9 can be broken down into 3 times 3. 21 can be broken down into 3 times 7. 24 can be broken down into 2 times 12, and then the 12 can be broken down into 2 times 6, and 6 can be broken down into 2 times 3. So now let's take a look and see all of the factors and drop down the maximum number of times that they appear. So 3 appears twice in the prime factorization of 9, and once each in 21 and 24. So the maximum number of times is 2 times, so we're going to bring down a 3 times a 3. 7 only appears in the prime factorization of 21, and it appears once. So we'll bring down a 7. And then finally, we have the prime factor 2, which shows up 3 times in the prime factorization of 24 and 0 times in the prime factorization of 9 or 21. So we'll drop down a 2, 1, 2, 3 times. When we multiply all of those together, that leaves us with 504 as our least common multiple. For our final example, we have the numbers 7, 98, and 16. So let's find the least common multiple. 7 is already a prime number, so it cannot be factored any further. 98 can be broken down into 2 times 49, and 49 can be broken down into 7 times 7. 16 can be broken down into 2 times 8. 8 can be broken down into 2 times 4, and 4 can be broken down into 2 times 2. So now let's drop down the maximum number of times each factor appears. So 7 appears once in the factorization of 7, but it appears 2 times in the factorization of 98. So we're going to drop down 7 2 times. The only other factor we have here is 2. 2 appears only once in the prime factorization of 98, but it appears 1, 2, 3, 4 times in the prime factorization of 16. So we're actually going to drop down 2 4 times. So when we multiply all of that together, we get 784. And that's going to be our least common multiple among 7, 98, and 16.